Welcome. Today, we're going to break down something pretty amazing, a real-world, high-throughput application that's built on the Cardano blockchain. We're talking about a system that has to handle a massive amount of data to prove the products you buy are the real deal.
But before we dive in, I want you to just look at this number, 5 billion. Just let that sink in for a second. This number is at the heart of the challenge, and it really frames the sheer scale of what we're about to explore. Okay, here's how we're going to tackle this. First, we'll look at the 5 billion QR code problem itself. Then we'll see why they moved from a classic database to the blockchain. We'll get into the weeds of their back-end engine, see how they actually get the data on-chain, and then explore why Cardano's specific design was the right fit. And finally, we'll see what this all looks like out in the real world. So let's start with the problem. Counterfeiting is, a massive global issue. The project we're focused on, iCheck, is right there on the front lines in Vietnam, tackling this head-on. Their whole mission is to give people confidence that the product they're holding is authentic.
And this isn't some small niche, not at all. I mean, just look at the economics of it. The market for this kind of anti-counterfeiting tech is already huge, and it's projected to be worth almost $500 billion by 2032. That's the scale of the fight for trust and authenticity.
Now, this slide is absolutely crucial. It shows that iCheck isn't some startup with a cool idea. No, they are a massive, established player, 25,000 business clients. And hey, there's that number again, over 5 billion QR codes already issued. This is a huge operation that was already working, which makes their decision to adopt blockchain even more interesting.
So that brings up the big question, right? If your system is already handling billions of codes for thousands of clients, if it ain't broke, why fix it? Why go through all the trouble of re-architecting everything to use a blockchain?
And boom, here's the answer, straight from the team. It all comes down to one word, transparency. Yeah, their old system worked, but it was basically a black box. You just had to trust them. But the government and their customers started asking for more. They wanted proof. They wanted a system where the history was undeniable. This really nails the before and after. They moved away from what's essentially a trust me model, where one company holds all the keys, to a verify me model. With Cardano, the records are transparent, the history is there for anyone to see, and most importantly, it's immutable. It can't be changed. You're no longer trusting a single company, you're trusting open source code and mathematics. That's a huge leap.
Okay, time to pop the hood and get into the really cool technical stuff. You can't just point a system that gets millions of scans at a blockchain and cross your fingers. You have to build a serious engine that can handle what is basically a data tsunami.
So, the whole idea behind their new backend is something called reactive programming. The best way to think about it is this. Instead of processing requests one by one in a long line where everyone has to wait, you're dealing with a constant, flowing stream of data. The system is always moving, always processing, and it never gets blocked waiting for something to finish. And I absolutely love this analogy from the reactor docs because it's just perfect. The data is on an assembly line. It comes in, gets put on the conveyor belt, and different workstations do their job as it flows by. The line never stops. And that is exactly the kind of efficiency you need when you've got this nonstop flood of QR code scans coming in. For the tech stack, they went with modern Java and a framework called Spring Web Flux. The main thing to get here is that this whole system is built for this non-blocking asynchronous style. It's designed to handle a mono, which is like a single data event, or a flux, a continuous, never-ending stream of events. For a system processing QR scans 24/7, that flux is the secret sauce. All right, so we've got this incredibly efficient backend that's processing data as fast as it comes in. That's awesome, but that's only half the story. How do you actually get that information recorded permanently on the Cardano blockchain? The key is a Cardano standard known as CIP20. You could think of it as a way to attach a little note or a memo to a transaction. It's super clever. They use the label 674, which, if you remember old T9 phone keypads, actually spells MSG for message. So they're literally embedding the product scan data as a message right into the transaction itself. So here's the entire journey, from scan to chain. Step 1. Someone scans a QR code. Step 2. That data flows into the reactive backend we just talked about. Step 3, the system grabs the important info, bundles it up into that CIP20 message format, and finally, Step 4, it submits it to Cardano as a transaction using the Block Frost API. It's an elegant pipeline from a physical action in the world to an unchangeable record on a global ledger.
Now, to make all this work, you need a bridge between their Java world and the Cardano network, and that's where this tool comes in, the Blockbean Cardano Client Library.
This is the critical piece of software plumbing that does the heavy lifting. It builds the transaction, attaches that CIP20 data, and sends it out to the network, handling all the complex details behind the scenes.
So this leads to a super important question. There are a lot of blockchains to choose from. Why Cardano? For a project that has such intense demands for high throughput, what made them choose this platform? A huge piece of the answer is Cardano's core architecture, specifically something called the EUTXO model. Now, we're not going to get lost in the weeds here, but the big takeaway is that this model is fantastic for doing lots of things at once, for parallelism. It's kind of like having a 10-lane superhighway for transactions instead of a single-lane country road. You can just handle way more traffic without creating a jam. And this quote from the folks who built Cardano really hits the nail on the head. The UTXO model actually encourages developers to build for scale from day one. By splitting up the data across many different places, you're essentially creating more lanes on that highway. That's how you get the kind of massive throughput you need for a project that's dealing with billions of items. Okay, so let's pull it all together. We've seen the massive problem, the scale of the business, and we've gone deep on the tech. So what's the bottom line? What did they actually achieve here? Well, here it is. They've successfully built a system that's incredibly fast, it's ready to scale even bigger, and it's resilient. But the real victory, the whole point of the exercise, is that last bullet point. They now have what they were asked for, a tamper-proof, publicly verifiable history for every single product, a single source of truth that everyone, from the manufacturer to the government to the consumer, can trust completely. What we've looked at today is so much more than just a cool tech project. It is a powerful, real-world example of blockchain being used at an incredible scale. And it leaves us with this final question to chew on. What happens when every product we buy has its own permanent, verifiable story? How does that change our relationship with the things we buy and the trust we place in the companies that make them? It's a pretty powerful idea.